Next part of the lecture is vector data. As has already been mentioned a couple of times, rasters are storing this array of or matrix of values. We've got these cells where the position is implicit. We start counting at one corner and then just add on more and more information until we get to the end of the line and then jump down and then build up from there. Whereas with vectors, each piece of information has an explicit coordinate. We are storing information about that point. We build up everything from points, from nodes. We say, here, do something at this particular point. Now, whether that's a part of a line or a polygon, but we go to this particular point. And this data may, depending on what type of data we have, it may be X and Y data, or it may be X, Y, Z data. So we may have 2 coordinates or 3 coordinates in a tuple, and then some sort of table data, information in a database about that point or about that object that's being represented. And we can build these up, as it says there in the text. We can go from points to lines to polygons to collections of objects. We can build them up in that sense. So if we think back to a previous slide in this lecture, we have this continuous data in a raster, and that's all very, very pretty, but I said that it's just grey stuff. We don't know anything about it. Now, I know what's in this image, but it's not particularly useful otherwise. It depends on what you want to do with it, obviously, but if you actually want to find out what's there, well, then it's better to have some actual objects. So here I've drawn in a line and I said it's a ridge there. And here we have our point here as a benchmark. You couldn't possibly even see that in the original data. I know there's a benchmark there. There's a survey point. And then there's a lake here, that flat area. That was a lake in this area down here. And here's a glacier, and I could start putting in more and more lines in there. We're making definite objects. These things exist at these locations rather than subjective. Well, that sort of looks like it could be a thing up there. Where's the boundary of that? And everything that is that object, they're homogeneous objects. That whole thing is the lake. It's a lake, and it's the lake over this entire object. There's no variation within it. But that whole area belongs to the lake. We also have information now. We know that this is a lake. It's water. It's not just a flat surface. It is, if I were to actually map in and draw an object here for the glacier, we would know they are distinct things. This is ice, and this is only ice part of the year. This is water. In fact, that's probably water from this glacier, but doesn't matter. So we have this other data, more information connected to these objects. This is something that we didn't really have. We could connect a lot more information to this now. More beyond that we could probably do, or realistically do, with class data in a raster. We can connect all sorts of other information to these objects through a database, because they are distinct objects existing in a particular location, whereas a raster has class data which applies to any object of that class, regardless of where it is in the image, and that becomes slightly complicated then to deal with, whereas these are specific things at particular locations. So here we have, again, a point, a road, and a polygon, lake thing, something, and we code those up. We go from reality to our vector format data stored here, simplified, put into a coordinate system, and then we convert everything into nodes, points, with explicit coordinates for each node. So each point where something happens, where there's some information change, something has occurred, we put in a node. And then we can connect these nodes. We have another table that says, so we've stored this as a table with our information there, and we have another table saying, well, all of these nodes, go and get that node and build up a line. These are the different lines that make it, and they have these nodes to build them up. And then we can connect those up to make more complicated objects, such as polygons. And we can also connect other data into this, adding more and more information, what exists in our database from these different nodes. Points and lines and polygons become data in our database. This is one way of storing. This is the typically relational database. We have other ways of storing vector data, but it's this essential idea of the point structure and the database, storing information about those points and then connecting them up and adding more information. And we can do this with in several different ways. Similarly to the raster situation, where there are many different file formats, unnecessarily many. Again, it's the same situation with vectors. We have a lot of different ways of storing data. Traditionally, I would say traditionally, we have the shape file with shape and DBF. So the shape is storing the spatial information. DBF is our database. We have this was a proprietary format owned by Esri. They made it completely open many years ago, and it's been kind of dominant for a long time. It's starting to lose ground now. People are moving away from this and going into geodatabases and geopackages, depending on what you prefer. But there are also we have different SQL based. These are spatial variants of SQL databases that exist outside of GIS, and we've sort of added on the spatial functionality to these. So PostgreSQL has acquired a spatial component, so it becomes PostGIS, and Spatial Light is SQLite with spatial functionality as well. This actually is included. This sort of goes into the geopackage. The geopackage uses SQL. Geopackage can also store rasters, as can the geodatabase. But it's a technical detail, not really something to be worried about now. And if you remember, going back to previous courses, the SQL language is what we, generally speaking, are going to be using with our geographic data in a lot of cases, where we can then search the database by building up queries. And the basic SQL query that we're interested in is the one that looks like this. Select column name. Column name is in our table is the header for a particular column. Generally speaking, in GIS, we can replace the column name with a star, which means all the columns, all the information there is to be had about this particular object. And the table name is the layer that we're working with. And then we have this where and then some sort of condition. So all of this, generally speaking, is done for us by the GIS. The only bit that we're interested in when we're working with the database, when we're searching for things, selecting objects, trying to gather information, is this where condition, where something looks like this or looks like that. All of this bit is done for us. If you're unfamiliar with this, please do go back and check previous lectures.